Hello, am I audible? Hey guys, welcome back. So I'm not visible. Here I am. So hey guys, welcome back to Codecules. Today is day number 24. If you are new here, my name is Harshit and I am a final year BTech undergrad who has started the series for. Am I too loud? Here I am. So hey, Codecules. Today is day number 24. If you are new here, my name is Harshit and I on her final year pregnant who has students. Let me connect my words with my phone. So, okay. And today we are going to solve linked list problems. First, we will learn in the first half, we will try to learn the all the concepts of linked list. I hope I am audible clearly. So, and today we are going to solve uh, and today we are going to solve these problems. First, we will learn in the first part on the concepts of linked list. I hope I am audible clearly. Okay, so we are back. My what happened? So finally we are ready to start. Let's go. First, let's update our Notion and क्या मेरी आवाज ठीक से आ रही है? If anyone is watching. Yeah. Okay, so it is day number 24, and today we are going to start step number 6, that is linked list. Okay, in the Striver sheet, linked list in Java. Okay, so we are ready to go. Let me just put the problems in our to-do list for today. So the very first task will be that we learn the fundamentals of linked list. So, okay, and we have to do it right now. And then we will start with the Striver sheet. Like, okay, it's first step is also the same. Introduction to linked list, learn about structure and how node represented. Okay. Then the first problem after that will be inserting a node in a linked list. So let's put it here. Inserting a node in a LL. Okay. And then the next problem will be deleting a node in LL. And the next problem will be find the length of the LL. Okay, learn reversal. Okay, it is easy. So find the length of LL, and the last will be search an element in LL. Search an element in LL. So I think these problem now I can do. Yesterday that I had started. सिमिक नेनवाल इज सेइंग भाई आप इतनी कम वॉचिंग में कैसे पढ़ा लेते हो? ब्रो, आई एम नॉट टीचिंग, आई एम जस्ट डॉक्यूमेंटिंग माई ओन लर्निंग जर्नी. So I myself is trying to learn these topics for the first time, okay? And sometimes people join and ask how you did it, so I try to explain them as well. And if you are in the same journey, trying to be consistent and disciplined, you can join us together. We are building a community of coders where we can help each other, right? So I'm not a teacher, but I can be your mentor. I can help you and I can share my experiences, how I am like getting through this journey, okay? नो एडिट एचडी. हाँ ब्रो, लाइक मैंने डिसाइड किया था कि 7:30 से ही करूंगा, सो लाइक अब से रेगुलरली 7:30 से ही करूंगा, वेन एवर पॉसिबल. सो when things are in my favor, I try my best to start at 7:30. So let's start with linked list. Okay, these five problems are very basic. I think we will be able to solve these problems in an hour. And then we will try to learn about doubly linked list today itself. Okay, so let's add lecture number 2 as well, or duplicate and place it here. Lecture number 2, doubly linked list. आयुष सिंघल इज ब्रदर डे 24 पर लिंक लिस्ट फ्लो हो गया ना? Yes bro, very slow, but I can't fake it bro. It's not possible for me to like quickly learn everything. I'm just trying to learn. मतलब पहले मैं सोच रहा था कि like run after the numbers to solve all the problems as quickly as possible, but I will not remember anything after day number 45. So I'm just trying to learn as much as possible instead of doing all the problems. And if we are not able to solve all the problems in 45 days, then we will try to do them in 50 days. If not in 50 days, then we will try to do them in 55 days, but not more than that. Okay. From 0 to 400, crazy work. Bro, we are still away from 400. Maybe today we will be a family of 400 subscribers. Okay, so let's get back to the problems. And today we will try to solve these problems as well. Let me duplicate it and place it here and update. So, introduction to doubly linked list. Now, insert a node in DLN and then delete a node in DLN. Okay, so and reversing a DLN. So, one crazy thing we discovered is how we can like learn with the help of AIs, right? And without getting the actual solution to each of our problems. So I created this text file yesterday for learning linked list here itself without going anywhere else. So first, our first goal is to learn and solve these basic problems, like 20 basic problems that will build our fundamentals and strengthen us to solve difficult problems later. Okay, so is it visible, right? Yes. So these are the 6 phases that we will go through today for learning linked list. And let's get started, I think. Okay, first let's try to solve these basic problems that were there yesterday. In Striver sheet, he has explained it in context of C++, I guess. Okay, these are also explained in this. I think it is the time to get started. 7:45, right? Hmm. So anyone of you is at linked list? Are you learning linked list already, or like you are yet to start linked list? So let's create a node class. I think we don't need to use this mm, browser right now. Mm, so we should full screen our VS Code. VS Code. And is it visible? Yes, it is visible. So let's get started. Let's add one more file here. Let's create a folder for day number 24. And let's go move these files, linked list theory to 24, linked list problems to 24, and linked list basics. Okay, so day number 23. आज लिंक्ड लिस्ट खत्म. लेट्स सी. मतलब मैं पढ़ना स्टार्ट कर रहा हूँ लिंक्ड लिस्ट अभी तो. We are slow, but it's okay. Like now I'm not trying to run after the numbers. Let's run after the quality of problems that we solve. Okay. So let's start. The problem number one is create a node class. Let's open a file and let's create a node class. Linked list we will use later. 6 to 10 questions highly repeated. I have no idea right now. Okay, so let's create a node class. Class node, and let's have a data inside, and then node next. Okay, and should we create a constructor right now? Okay, one more thing we had to do. Open it side by side. Okay, so here it is. File. Our first goal is to create a node class. Okay, so this is the node class in linked that is used in linked list for learning. So our task is to create a node class that can hold an integer value and reference to the next node. So we have created a variable data which can hold integer value and a reference to the next node. Next node is also of data type node. So it will store the reference to the next node. Okay. So with two fields in data, use constructor to initialize nodes. So let's create a constructor. Mm, that will be like node data, and this dot data is equals to data, and this dot next is equals to null. Is it correct? If I need to open some resources other than that. Mm, Am I right at this point? So we have created a class node which has these two data types, and then we have created a constructor, and let's try to use it. So right now we are trying to like make our own user defined data type node which will act as will will be part of our linked list that we are creating by ourselves. We are not using the built-in linked list, okay, linked list class. So let's say we create a node and one is equals to new node and give it a value of 5. Okay, so we have created a new node and one, and what is the error? No unclosing instance of type. What does it mean? Mm, let's okay. Yeah. Okay, these are just problems. Like this, five. Okay. So here are the explanations that we're going to learn. Okay. So should we revise what is a linked list first, and then we will continue from. Okay. So let's say can't assign values to the constructor, I guess. Let me read the theory, then I will know what is the error. I have no idea right now what I am doing wrong. So, okay, think of linked list like a treasure hunt or a chain of clues. Each clue node contains some information data. Each clue also tells you where to find the next clue. So we are creating this clue which contains some data. Vamsa is back to our stream. Welcome back, Vamsa. We have just started learning linked list, so you can join us too. So we are continuing from where we left yesterday and like revising this theory part. So we can think of linked list as a treasure hunt or a chain of clues where each clue is a node, contains some information that is data, and each clue also tells you where to find the next clue. That means the next pointer. You start with the first clue head and follow the chain. The last clue says end or points to nothing. Okay, so should we do some visualizations as well? Let's open Scalidraw. Scalidraw, right? Scalidraw. So let's say this is the head. This is the head node. It will contain what? Two things it will contain. First, it will contain data, the value that is storing, or the element that it is storing, and the next pointer. That means the reference to the next node. Okay. So in this way, it is, let's say it is a head node of a linked list, and linked list is made by combining multiple such nodes. Okay. Let's create. So let's say the linked list has 4 nodes. Okay. So the first part of the node will contain the first part will contain the data or the value that it needs to store, and the second part will store the uh, reference to the next node. Okay, so let's say it points to the next node. Let's call this node as n1. Okay, and this node as n2, and this as n3. And as we are talking about singly linked list, that means we have only one pointer, okay, which points to the next node. Okay, so here it will contain the data that it needs to store for the n1 node, and it will also contain next for the next node. Okay, let's give some real values. Let's say the head contains 5 as the integer value. Like it is just like an array, but we will learn about the differences between the array list or linked list. Okay, and it points to n1. So we will store the reference of n1 here. Okay, and this will contain n2 as a pointer reference, and this will contain n3 as a pointer, and it will contain null. Okay, that means it is pointing to nothing. That means it is the last node of the linked list. Okay, so did it as well and add some real value. Let's say this contains 10, this contains 15, and this contains 20. Okay, so we have created a linked list of 4 nodes where the first node has the value that it needs to store, that is 5, and a pointer n1 that points to the next node. Okay, and the next node contains 10 and n2 points to the next node, that is n2, and the n2 node contains 15 and n3, a reference to the third node, sorry, fourth node, and fourth node, that is the final last node or of our linked list. It contains 20 as the data and null as it is the last node of the linked list. Okay, so it is connected to this and it is connected to this. So let's learn about the difference between array list or array and linked list. So as we know, we have studied in arrays that accessing the elements of an array can be done in big O of 1, right? That means we can access any of the uh, element in an array in constant time, right? Let's say this is an array 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the anyone knows that what is the reason that we use linked list instead of array list or array? So the first important point that we should remember is that arrays are mm, so so we know that arrays are memory locations as contains elements of similar data type in contiguous memory location. That means if one is stored at a memory location of, let's say, 000, so if one is stored at the zeroth index or memory location, let's say, or whatever, like let's say it is stored at something 00114. This is the memory address in our heap. Okay, whatever we at the starting, then that according to this, that all the other elements in the array are stored contiguous, like that if it is stored at this memory address, like at this memory address, then the next element will be at 015, 016, and so on. So in this way we have to assign the like memory adjacent to each element, right? So by if we know the address of the first element, we can identify the address of the last element when we know the length of the array. So if its length is 7 or 8, its length is 7. So what we can say? We can say that the last element will be at memory address of 21. Okay, 16, 17, 18, 19, 20, 21, right? But the problem is, let's make up pros and cons. So if we have to list the pros of using an array, is that we can access we can access any element of the array in constant time, because we know the memory address of any of the element. Am I wasting too much time explaining silly things? Okay, so this is a pro, but this is a fact that we have to store all the elements in a contiguous memory locations. And the con is, the main first con is that all the elements are stored in a contiguous memory location. And the second fact is that we when we try to insert or delete any element from the array, we have the time complexity becomes very high. That is, suppose if we have to remove 4 from this array, what we have to do? We have to remove, like first we will remove this and all the elements needs to be shifted by one places. Okay, which is not feasible. So we have to come up with a solution to overcome this problem. Okay, let's not talk about the whole array. I am telling you that is enough. So just to overcome this con, that is, we cannot insert and delete the elements of an array efficiently, we use linked list. Okay, so the problem is, let's just write the problem with array. Why we use linked list? Because the problem with the array was insertion and deletion. That is, insertion and deletion operations are not efficient. Okay, so this is the main problem with the array, due to which we use linked list. Okay, and how do we overcome this problem? Insertion and deletion operations are not efficient. Not okay. So to overcome this, we use linked list, and in linked list, to remove any node, let's say we need to remove the node number 2. What we will do? We will just update the next pointer of this node to point to the third node directly and remove this node. Okay, so in this way we can like update or delete any node without actually like shifting all other values. And we will just update this with n3. Now it will be pointing at the last node. Okay, now it is removed completely. But in case of array, if we have to remove 4, we would have like shift. First operation would have been removing 4, and then we have to shift all the remaining elements. Okay, shifting all other elements. But the problem is, if the size of the array is very large, we will have to shift large number of elements, right? So to overcome this problem, we use linked list. And let me revise. Linked list contains of nodes, multiple nodes, which contains a data and a pointer. Like singly linked list, we have node which contains data and a reference pointer which points to the next node. Okay, if we in this case the memory locations are not contiguous. That means the head is stored in some memory location, let's say 011, and the N2 node might be stored anywhere in the memory location, let's say 911. Okay, I'm talking about memory locations. Okay, assume it anything, any memory address. Okay, and the N3 is stored in anywhere in the memory somewhere. Okay, let's say 511 or whatever, but we can access them directly. Okay, now with the help of head, we can like access all the nodes in very efficient time. What am I saying? So this is all about linked list, and to traverse through the linked list, what we do, we get the head and use the head to go to the next. Okay, so let's talk about the drawback of linked list. We cannot like access the element in constant time. In array, the advantage was that we could access any of the element in meantime, like O of n, right? We could access these element in O of one, sorry, not n, O of one, right? But we cannot do this with linked list. We have to traverse through the head, like from the first node to the second node, then third node, then fourth node. Like if we need to find some element, we have to first go to the first node, then we will go to the second node, then to the third node, and we'll compare, keep comparing. So this is a drawback of linked list, but the use cases are different for both the things. Let's get back to the code part. So अरे यार यहाँ पे लिखा हुआ था ना कितना क्लियरली, इतना एक्सप्लेनेशन देने की जरूरत नहीं थी. So arrays are like apartment buildings. You can think of it as apartment building direct access, like you can access any of the room or the apartment by the door, index based, but you can, there is, this is very hard to add or remove apartment in the middle. Like you cannot add or remove apartment from a building, right? Or memory based, like if many apartments are empty, that means if you have created a array of 10 elements and मतलब array of size 10, but few of the memory addresses are empty, then they will get wasted because they will be using the contiguous memory location even when they are not storing anything. But linked lists are dynamic in size, easy to add and remove. That means if we have removed a node, it don't use that particular memory address, right, anymore. And then the same thing, dynamic in size and no memory waste, only allocates what you need. Like when you are using that particular memory location, only then the linked list uses that memory. But the problem is no direct access. जो array का advantage है वो linked list का drawback है. So before we code, you think of a real world scenario where you'd prefer a linked list over an array. So what are the real world scenarios where we will be using linked list? A music playlist to add and remove songs. Like when we like create a playlist of songs, we need to add and remove any song from the middle or anywhere, right? So in that case, we will be using linked list. And undo redo operations, like it's like stack operation. Stack is also implementation of linked list. Okay. And shopping cart, these are the real world examples for when we use linked list. So let's start with node structure. This is what I have already created in a file, and the constructor we need to give it a public node int data. Okay, this was right. And okay, initially points to nothing. We have created a constructor which will initialize the first node object, right? Now this is our demo class and main method. So we have created a node class which we will use. Short list is the only list I believe in, Vival is saying. But that is what we are not getting shortlisted. That is why we are working so hard here. Okay, so let's create a new node. Mm, Node, let's give it a name n1. Node n1 is equals to new node, and let's give it data 5 that I had explained in that Scalibro. But we are getting mm, x dot new is the instance of LLPC. What is this error I'm getting? Can someone explain? Mm, Okay, public static class. Okay, but here it is not. But we want to create node, right? Is this the right way of creating node class? Public static. But we use static keyword when we don't want to create object from the, yes, this is a constructor. This highlighted part is a constructor, and this is a node class that we have created. The node class consists of the data, integer type, and the reference pointer of node type, like itself. But I don't understand why we are using this static keyword here. Okay, for now, let's forget it. Like, move forward. We will figure it out later why we are using static and why we can't use without static here. Okay, let's create our first node. We have created node n1 is equals to new node with data 5, and let's create another new node, node n2. Okay, let's give it a name head first. Okay, like we had given in our example, and then we will create node n1 is equals to new node and store data 10. Okay, and how do we connect our nodes? So for connecting our nodes, we will like, let's creating nodes using a node class. Okay, and then connecting nodes. Although we don't have to do this much while we are solving the problems, but let's say head.next is equals to n1, that is the next node. Okay, it will store the reference to the next node, and n1 dot next is equals to null currently because we don't have another node to point it to. But let's create, if we have another node, n2 is equals to new node, and it stores data 15, and node n3 is equals to new node and stores data 20. Okay, so now we can connect it to the other pointers. Okay, so the n1 dot next will point to the next node, that will be n2, right? N2. Okay, and the next n2 pointer will be pointing to n3, and now n3 is the last node in our linked list, so n3 will be, n3 dot next will be null. Okay, so this is how we have created a linked list by using our user defined node class. And let's say we want to print the elements of our node class, like linked list. This is a linked list. Okay, we have created a class node for using nodes and creating node objects, but this implementation, the connection of all the nodes is called linked list. Or now let's say we want to print all the elements one by one. So what we will do, we will take a variable, or let's say head, like while head dot next, not head. Let's create some other variable. Mm, Let's say node current is equals to head. Okay, so we have created a current node. Let suppose it is like a I pointer. Okay, so while current dot next is not equals to null, that means जब तक के जो current वाला node है, current node is like a temporary node that we are creating to traverse over the linked list. Okay, so while current dot next is not equals to null, that means we don't until we reach the last node of the linked list, we will keep executing the while loop. Okay, so what we will do, while current dot next is not equals to null, we will do system dot out print current dot data. That will, it will print the data that it is pointing to, like, mm, data of the node it is pointing to. initially we have created current equals to head. That means the current temporary node is acting as the first node. Okay. Then after printing, what we will do, we will update it. How we will update? We will update current is equals to current dot next. That means now it will be pointing to the next pointer, and after the next iteration, it will point to the next pointer, right? And in this way, it will print all the elements of the linked list. It is right. Let's try to run it. So here it has printed all the elements except the like last element, because we are doing not equals to. When it becomes null, then it breaks it. What we can do to execute the last node as well? इसको do while में कन्वर्ट कर देते हैं. इसमें do लिखना पड़ेगा क्या? Do. क्या सिंटैक्स होता है do while loop का? Okay, and the condition is while while not equals to null. Okay, what we will do? We will update our first we will print the current data, that is current dot data, and then we will update current dot current equals to current dot next, right? So this way, first it will print and update and then check if it is equals to null or not. Let's run it again. It is still doing the same thing. What is the problem with this solution? देख लेता हूँ sheet में how they have implemented it. Following is the code. Following the treasure hunt, node current equals to first, while current is not equals to null. Okay, sorry, we got it. We are doing the next equals to null, but we will check if current is not equals to null. Let's say while current is not equals to null. That means it is the next pointer, right? Okay, then we will print SOUT current dot data and update current node with next node, next pointer or node, whatever, current dot next. Okay, now it will work fine. Now it is working fine. It is printing all the 4 elements in our linked list. Okay, so I hope I am clear with my thoughts, what I'm trying to learn. And at the end, we will print this is the end. So this was the first implementation, how to create node. Or one more thing, that this is just the implementation to learn what is done inside the linked list. But when we are using the uh, linked list interface from our collection framework, we will not have to do this much of things. We will directly using the methods predefined in our built-in package, right? collection framework. Mm, Now let's move to the next problem number one. Your task is to create a chain of four nodes with values 5, 15, 25, 35. Write code to print all the values in the chain. Count how many nodes are there in the chain. Find maximum value in the chain. So let's update to do these two tasks as well. Count how many nodes are there. Let's create a count variable. Let's say int count is equals to 0. And here we will keep updating the count plus plus. So it will keep a track of the number of nodes we are encountering every time. And we need to find the maximum value in the chain as well. So let's create another variable. Int max is equals to 0. And we will keep updating the max. Okay, the semicolon. And we will keep updating the max with math.max of max comma current dot data. Okay, so it will store the maximum value, and at the end we will return the SOUT. The number of nodes is um, count. Okay, and then we will print the maximum value. The max value in the chain is what? The max variable that we have been keeping. Okay, let's run it and it will give the maximum value. The number of nodes is 4 and the maximum value in the chain is 20. So we got this much of the linked list part. Okay, so I hope I'm not wasting so much of the time, but it's fine. Now we have already learned about this. Now the solution, this is the solution. It is completely same as we have done. So skip it. Let's learn the concept number two, the linked list class. So right now we have already learned about the node class, how we create the node class. Now we will learn about the linked list class, which will contain all the methods. Okay, if nodes are individual train cars, then the linked list class is like the train conductor who knows where the train starts, that is the head pointer, can add new cars to the train, can remove cars from the train, can tell you information about entire train. Okay, so we will have to create a linked list class now. So mini example, basic of linked list class. What it says, it has created a linked list class public and created a private node head points to the first node start of the chain. And then there is a constructor which creates an empty list. This dot head is equals to null. That means with the current head is pointing to the null node or the null pointer. Okay. Check if list is empty. This is a method which will be used to check if the list is empty. We have created this linked list class. Inside this, we have this linked list empty list which has nothing inside. And then there is a method to check if the link is empty. We will return if head is equals to null. That is, initially we have created the null pointer, right? Then display all the elements. To display all the elements, if head is equals to null, print that the list is empty and node current. Okay, it is the same method that we used to like traverse over the linked list or the chain of nodes that we had created. Then get the size of the list. These are all the same things. So what we have to do, we have to create a node class separately and the linked list class. Then we will use this linked list class to create, add, remove, display all the nodes of the linked list. Okay. So here is the interactive exercise. Build your linked list class. Uh, let's create a new file. Okay, let's call it underscore 01 underscore ll. Okay, and keep it this side. अरे इसको डॉट जावा तो दिया नहीं extension dot java. Okay, so we will create a Java class. What is public class? Public class underscore 01 ll. So इसको नाम चेंज करके लिंक लिस्ट कर देते हैं. लिंक लिस्ट. ओके. नाउ इट विल अपडेट. भाई अपडेट कर देना और कुछ से लिंक लिस्ट. ओके. So now it is fine. Remove this public. Now it is fine. So okay, extend the basic linked list class by adding these methods. We need to, okay, these method we are copying directly. This is the constructor and the check is if empty and traversing. So we have copied the basic structure of a linked list. Okay, but we also need to have a node class, right? Where is our node class? Where is our node class? We will copy it and where is our file? Linked list.java. Okay, here it is. And we will add it inside our linked list class. Now all the heads are valid. This dot head. Okay, we have to change public node. What is head here? This dot head is equals to null. How they have created the node class? Where is the definition of heads? Find maximum it is also assigned. This dot head. Okay, so they have instead of naming it as next, they have named it as head. Now it should work, but it is not that simple. What is the problem with what is wrong with this? Okay, it has to create a node object, right? Mm, Node height is equals to new node null, but it cannot be empty, right? Okay, this is good now. Okay, ये रहा ना यार private node head. They have created this private node head already that we have not copied. Private node head. So this is what we were missing. So now let's continue. These are all the basic method that we have copied already. Now what is our task? To check if it contains some value, return true if the value exists in the list, and get first returns the data of the first node, or -1 if empty. Get last returns the data of the last node, or -1 if it is empty. Okay, so now let's create this method number one. That is our task. This is public int size. Now we need to contain. We need to check if it contains some value or not. Let's create public contains int value. Okay, public int will return true, right? Boolean. Okay, so we need to compare, we need to traverse. So what is the method for traverse? Mm, let's say if is empty, like what is the head dot empty, right? Head dot is empty. What is the right? And then we will traverse over it. While head is not equals to null, we will keep updating. We will check if head dot data is equals to value. If it is true, then we will return true, right? Return true. Otherwise, else what we will do, we will update the head. How we will update the head? Head is equals to head dot next. Okay, so it will get updated and we'll keep a check. It will return true, it will return false. And if it fails to find the answer, it will return false, right? Okay, I think this method should work. Contains, and we will try to check it as well. Mm, Public class linked list. How to like implement these methods? So we have created this. Okay, we have to create a separate variable node that is current. Okay, let's say node current is equals to third, and then we will put a check on current node and current, and we will update the current node. Okay, I got it. So till now it is right. Okay, so we have added this, and to like do implement these methods, we have these classes. You can add them here. Now we have all these classes. How to implement it? Okay, so we have this linked list class, okay, inside our own files. Traversal patterns, visiting each node, pattern traversal with counting, traversal with processing, some other values, master traversal. So these problems can be solved using our linked list class, right? So let's say if we are solving the chapter concept number 3, let's create new file and we will import a linked list that we have created in our new file. That is traversal pattern. So underscore 002 underscore traversal traversal dot java. And inside this, what we will do, we will import, import, import what underscore 24 underscore ray dot what linked list, correct? Right, linked list. So this way we have like imported our own user defined linked list class. Okay, so we will use a linked list class to create a linked list. So how to do that? Linked list L is equals to new linked list. Okay, so we have created a new linked list. Now what we will do, list dot add, right? What is the method that we have created to add a new value? Mm, L dot display. L dot display. Okay, it will display all the elements inside the linked list, and then we can check if it is empty. If it is empty, it will return empty. We can get the size. We have not created a method to add the values, right? We have not created a method to add the values in our linked list. So let's get back to a linked list class that we have created, and let's add a method to add an element, right? So let's say public, what it will do, public void add, okay, int value, and it will, what it will do, head dot data is equals to value. But how will it update the next pointer? Let's see. There will be, let's l dot add 10. Okay, so it is working. Then l dot add, when we add a next node, how will it update the mm, reference or the pointer? Like if we use this, if let's say node current is equals to head, and if current dot next is equals to null, then simply just add the value to the head dot data. Okay, not head dot data but current dot data. Else, अरे बट इनिशियली तो वो नल पॉइंटर पे ही करेगा ना, न्यू नोड क्रिएट करना पड़ेगा हमें. So how will it happen? If the current node is null, so then we will create new node. Let's not get into it right now. We will think of it later. Okay, forget about adding the elements right now. We can display. So what is the task that we have given? We need to traverse through the linked list. Okay. Simple traversal, public void print all had got okay. But how to do this when we don't know how to create a linked list? Find the second to the last node. Okay, I got it, I got it. But where is our linked list? Okay, insertion and deletion. Okay, it should be like node, new node. तो चलो ठीक है बना देते हैं. Add method बना देते हैं. So let's say public void, public void insert. Okay, यही वाला method ऐड कर देते हैं. Insert और simple add. Okay. What it will be int data. We will add integer data to our linked list, and for that we will have to create new node. New node is equals to new node, and data will be data. Okay, and then if the head points to the null, if head is equals to null, what we will do, head is equals to new node that we have created and will return. Okay, it is fine. Mm, And we will connect our new node to the last node. For that, we will have to find the last node. Node current is equals to head, and while current dot next is not equals to null, what we will do, we will update current with current dot next, right? Spelling mistake, okay? Current will be current की जगह current लिखिए. Okay, and then we will connect our node. Okay, this is the curly braces bracket that I was using. And then we will connect the newly created node to the previous node. Current dot next will point to the new node. So this is the method that we can use to create new linked list and add multiple values to it. Okay, so now our linked list class has a add method. So we can add values to our linked list. Let's say l.add. What value we want to add? 5, 5, okay, 4. L dot add, L dot add 5, 5, okay, L dot add 10, 10, L dot add, what will be the data? Let's say 20. Okay, so we have created a linked list and added these four data to a linked list. Now, what we need to do? Let's get back to the task. Okay, what was the task? These were the challenges. We need to find the second last element, count even, get at. Acha, this is the third exercise. The first exercise was simple traversal. What we need to do, enter from the entrance and visit each node one by one. Mm, Pattern one, simple traversal, visiting each node. And what we need to do, okay, there's nothing that we need to do. With condition, find specific value. So These are just the classes that we can copy paste in our class index of sum. Okay, we need to implement these methods. So let's copy these methods. Just copy this part. These are the four traversal methods that we will add to our linked list class. That is here. Before our node class, right? We will add these classes here. Okay, let's paste down here. Now we have all the methods that we need to use. Now let's do the problem. We have created a linked list with our user defined linked list class that we have created by ourselves. Now we need to implement traversal based methods that also we have created inside our linked list class. Now what is the first method that we need to implement is find second last. So L dot find second last. First, let's find 5. What will it return? What it should return? Let's run it. List is empty. Why? Why the list is empty? We have added this. Our add method is not working correctly. Where is our add? Okay, it has just printed the first thing that we asked it to. L dot display, but find will do what will do the find method. Where is it? Where is it? Find, get first, get last, find. It will check and return null, not found. And what will it return? It will return node only. It will return node. Okay, so it is returning only the node. So let's print this, whatever it will return. SOUT L dot find L dot find 5 and dot data. Okay, data is there. It will return the index. Okay, not the index, but the location, memory address of the linked list. So this is the memory address of that particular node where the value is equals to 5. But can we give the node some indexes which it can return for us? Return the data of the second to the last node. So let's return the data, but we want to find the index, right? I'm a little bit confused. There are so many methods. Find second to last. This is the method that can be used to find the second to last. Count even numbers. Return count. Okay, so our task is to create these methods only, not implementing them. Why am I learning these many methods when I can use the built-in linked list class? Master all insertion, insert at beginning, insert at end, insert after, before. Okay, we need to search for the value first. Test each method the value with empty list. Okay. Hmm. Let's try to solve the problems in a sheet if we are able to. If we are able to do so. Inserting a node in a linked list. Okay, there is no. Let's use Striver's platform for doing so. So given the head of a singly linked list and an integer x, insert a node with value x at the head of the linked list and return the head of the modified list. Return the head of the modified list. So we have a list class, list node int value, list node equals to next. Okay, so definition for singly linked list. List node is equals to value and next equals to null. So we have the head node and we need to update and blank, completely blank. So input is we have this linked list and x is equals to 7 and we need to add x to the head. So we will have to create a new node, let's say um, private list node and then list let's say list nine h is equals to new list h dot data as a picture x and h dot next is equals to head. Complete the conversion. Why am I confused? We have given a head of a singly linked list and an integer x. Insert a node with value x at the head of the linked list. So it is same as I created a first nodes. So it is linked list class. I got it. We created this method. Okay. These are the traversal methods. Simple traversal, print all method. Okay, so let's say what is the privacy and dot print all. Let's find it. And it has printed the list. Okay. Let's not check this list dot display and open it here. Okay, so the first method we have used is at the top. Okay, so print all method we have used. Now, if we want to find a specific value, we can get it reversal with counting, finding the position, index of. Okay, so then we can use L dot index of 5. Okay, this is what it was. Let's run it. Index of 5, it has returned, but we need to print it. So the index of 5 is 1, that is correct. Okay, let's implement the fourth traversal sum, that is L dot, okay, SOUP, L dot sum. Okay, let's run it. It has written 39, which is correct as well. Okay, now I'm getting it. So these are the methods that we have created and we can use. Return the ticket. These get first, get last. These are also okay. These are the interactive exercises that we had to do. So the first part is done, and then basically the rest is done. These method return to value first. Get first returns the data of the first node or minus one is empty. So we had to create. Okay. So find index of and sum is already implemented and also contains print. Okay. So contains is already there. Method contains add display print display size contains. So the first method is contains. We need to check if the value is there in our linked list or not. It is already there. Get first is also there. Head dot data. Okay. It is the first node that we have. Okay. Get last when head is equals to null, return minus one. And node dot current is equals to head, and while current dot next is not equals to null, current equals to current dot next, return current dot data. Okay. Print all find index of sum and these are the last two. Okay, get first and get last. We can also use these methods, get first and get last. So SOUT L dot get first. It will return the first element in the list linked list. SOUT get last. It will return the last value of our linked list. Get last created नहीं है क्या? Hmm, in our linked list, get last is there. Get last is there, but what is the problem? Get last. Okay, sorry. L dot get last होगा ना? L dot get last. Okay. So it will return the last element of our linked list L. Let's run it. And so it has returned the index of 5, then sum of all the elements, then the first element, then the last element. So it is working fine. We are getting it. We got it. Then the third part is traversal pattern. Traversal is like walking through a museum. You start at the entrance, you visit each exhibit, move one by one, you follow the path markers, next counter, you know you're done when there are no more exhibits. Print all methods. Uh, yeah, that these we have created already. Find the second last, count even, get that. So these are the new methods that we need to implement. Now let's try to implement these methods by ourselves only. So in our linked list class, before our node class, let's create find second last. What we need to do, find the second last element, right? So public and return the data of the second to last. Okay, ठीक है. Second last वाले का data return करना है. तो what it will be int and find second last and second last of, is it empty? Will it be empty? Yes. And this method will return the data of the second last. Okay. So node current is equals to head. So while, how do we get second last? Mm, So while current dot next is equals to null, and we will return current dot data. So it will return the, otherwise if it is, अरे otherwise क्या होगा? Hmm, current dot data is integer type. And what is the problem? अरे यहाँ पे रिटर्न स्टेटमेंट नहीं आएगा. रिटर्न स्टेटमेंट बाहर आ गया. करंट डॉट डेटा इसमें कुछ नहीं करना है एंड करंट को अपडेट करना है करंट is equals to current dot next. Now it is correct. So we have implemented the find second last method. विशाल मौर्य जी, हेलो, कैसे हो आप? आई एम फाइन ब्रो, हाउ आर यू? हाउ आर यू डूइंग? हाउ इज द preparation going? What are you doing? What is up? So we have implemented the find second last method. Okay. Now we will count even. Like we will make a method to count even numbers and we will use them later. Okay. So let's create a method public count even. We need to return the count of the even numbers, right? So we will return int and even, count even, and then how we can count? Let's create node current is equals to head while, and let's create a count variable int count is equals to 0, and while current is not equals to null. So we will iterate over each. इसको small letter में करो. Okay. Current is not equals to null. What we will do? We will check if current dot data modulus of 2 is equals to 0. If it is true, that means if the current data is divisible by 2, that means it is even, then we will increase the count. Okay, we will increase the count. This is it. And also we will have to update current. Current is equals to current dot next. Okay, and then we will return our count. Now it is correct. So this is the method number 2 for this challenge. And then let's create the next method, that is get all method. Return data at a specific index. Get at, okay. So we need to return the data at a specific index. Okay. To return the data at a specific index, we will create a method public return the data, right? Int get at and what we will do, we will create a variable count is equals to 0, int count equals to 0, int count equals to 0, and then a new node current is equals to head and traverse through the array. Okay, it should also have a index, right? Int index, idx or index. Okay, so we know the index to of which we need to return the data type. So while current is not equals to null, we will keep iterating over the linked list and we need to return the data of the index, data of the given index, right? So we will update current, let's say, if count is equals to idx, then we will return current dot data. Okay. Otherwise, what we will do after that, we will update current with current dot data. Okay. I'm inside the while loop and I'm trying to update it. Oh, sorry. Current dot next, na bro. Next. Okay. Now it is fine. And then we will return. If it is not found, what we will return? We will return. कुछ तो return करना पड़ेगा. Index given है. And we need to return the data at that particular index. And we need to update the count variable also, right? So after that, we will update count plus plus. It is correct. Now, and we cannot return every time. Okay, we will break the loop as well. If count is equals to, अरे तो ये while statement ही वो हो जाएगा ना यार. जब तक जब तक हमारा count is equals to count is not equals to idx, we will keep iterating count plus plus, and once it is equals to the index, we will return current dot data. Now it is right. It is accurate. And then the next method is we need to reverse. We need to create a method to reverse the linked list. So, okay, print reverse नाम का एक मेथड बनाना है जिसकी हेल्प से हम पूरी लिंक्ड लिस्ट को रिवर्स कर सकें. This will we will create this method later. Let's try to run all the methods that we have created recently. So we have created a linked list L using our own user-defined linked list. Okay, here it is, and added these data to our linked list as the first, second, third, and fourth data or node. Okay, and this method we have created to print all the nodes. And let's check the last four methods that we have created. So and we will print data of the second to last node. So we will print L dot second last, find second last. Okay, find second last. It will return the data that is on the second last index of our linked list. And the next method that we had created is count even. L dot count even. It will return the number of even numbers in a linked list. And the next method that we had created was get at, like return data at particular index. Let's say L dot get at the index number 3, that it should return 20, right? And the next print reverse method we will do after a short break. Okay, let's run that. So it is working fine. The find second last element was first it has printed all the elements. Second last method is not working correctly. What is the problem? Okay, print all will print all the methods, and then the find second last is returning 4. That is the head. It is not correct. So we need to check or find second last method that we have created. Find second last current head current dot next net equals to null. I think now it should work. Let's try to run it. Why it is returning the head? And number of even number is correct. That is 3. 0, 4, and 2. Okay. The find second last method is not working as expected. If head is equals to null, head dot next equals to null, then return -1. Node current, current dot next is not equals to null, current. ये तो सही इम्प्लीमेंट किया था ना, आई गेस. Current dot next, next dot next. Oh, sorry, not equals to null. Sorry. Not equals to null. Okay, now it will run correctly. Where is our program? Where is our program? Here it is. Let's run it. Now it will return 10. It is correct. Hey guys, we are back already. Hello, welcome. What welcome? I am back. Should I turn on the camera? Oh, people came and gone. So we are back. Am I audible? Should I increase the volume? I'm gonna raise the volume. Oh, okay. Wait, this to be audible to everyone here. So I'm speaking slowly, but my voice should be coming loud and clear. Oh, I came back quickly. So let's solve the problems, right? First, let's check what different problems were there in our problems list. Okay, let's keep it full screen. And remove this book, Java. Linked list theory, linked list problems. Okay, and keep it aside. Reduce the size. And here we are. Problem number one, create a node class. We have done that. Print a chain of nodes. We have done that. Count the nodes in a chain. We have done that. Find maximum value in a chain. We have done that. Create a linked list class. We have done that. Add elements to and append. So we have done that as well. Okay. Learn to build a list by adding elements to the tail. Task write and append into data method that adds a new node with given data to the end of the list. So we need to change the name of the method which we were using with append. Instead of add, we should make it append. Where is it? Where is it? Where is it? Where is it? Add method. Here it is. We should name it append. Okay. So this problem is also done. And create list from array. This we need to learn how to do this. Insertion must be insert at the beginning. Okay, these are the problems. Specific position, insert after given value, insert in sorted order, deletion, delete from beginning, delete by value, delete at position, search and access, finding and retrieving data, advanced pattern problems. These are was the linked list, find the middle element, detect if list has a cycle, these two parts we have already done, phase 1 and phase 2. Now we need to master insertion and deletion of linked list. Detect cycle, find middle element, detect delete by value, common pitfalls to avoid, null pointer exception, always check, node not equals to null, using track of previous node during deletion, find complexities to remember, such operation is ON must traverse sequentially, insert at beginning is 0, 1, direct head manipulation, insert at end is n, O of n, must traverse to the end, deletion in reverse. And what is the point of using linked list? This progression ensures to build a rock-solid foundation in linked list, preparing to for both academic understanding and technical. Discipline. Okay, these are the finest problems. Create a node class एक पे supplement the two print a chain of nodes. यहाँ से स्टार्ट करते हैं वो तीनों फाइल्स तो बन डे 24 के अंदर लेट्स क्रिएट let us create basic problem set. Mm, Inside it, create new files. mm, Problem one, one Java. Let's start from problem number two, right? Problem two dot Java. Keep it here. Mm. And inside this, we need to import linked list, that is underscore. It is not visible. Why I know that? Because I can delete this window and keep all the files for itself. And this is 02 underscore print all nodes for Java. Okay, so first let's create a linked list. Okay, linked list, linked list equals to new linked list. And do we need to import Okay. So we have imported and linked list dot append. Oh, sorry, we need to first here's beyond and then we will create linked list. Ll is equals to new linked list and now in ll we will append one, then ll dot append two, then ll dot append three, then ll dot append uh, four, five. Okay, so we have created a linked list. Let's do some random numbers. Okay, so we have created a linked list from using our own method, own linked list class. Okay, that we have created user defined linked list class, and we are using that only. So print a chain of nodes. So we had created a method to print all method or display method to print the nodes, right? So what we will do, ll dot display. So this will print all the elements of our linked list. Okay, this is the linked list. Okay, 15, 24, 35, 44 and 53 and null. Okay, then what we need to do, this is done. Print chain of node, count nodes in a chain. So let's say ll dot count. We need to create that method. So let's create is empty is done, append is done, display is done. Then let's create count nodes, right? Okay, size will return the count of the nodes. So for count, we will do ll dot size. It will return the size of a linked list. Let's run it again. And it has returned 5. That means it has 5 nodes. Okay, so it is fine. Okay, then the next problem is find the maximum. We had created that maximum method that was ll dot max. Max. There is max. Had we had created, I remember, at first, get last, print all, find index of sum, find second last, count even, get. Let's create that max method. Public int max and let's say int max is equals to head dot data. Okay, and node current is equals to head while current is not equals to null. We will compare max is equals to max dot max of max comma current dot data. Okay, and then update current is equals to current dot next, and then we will return max. So we have created this max method and ll dot max. We need to print so SOUT ll dot max. Now it should return the maximum. Okay, so it has returned the maximum already. So this is also done. Let's write done in front of these. Done, done, done. Find maximum is also done. Then the problem number 5 is create linked list. That is also done. Add elements. That is also done. We have already done this right now. Create list from array. That is what we need to do now. Okay. Print all nodes. Let's create a new file that is create list from array underscore 03 underscore array array to list dot java. Or we can do it in the same. So let's say we are given an array. Let's say array is इसे नहीं है क्या LISG let's create a sample array like int arr is equals to copy the elements here. And let's say this is a array. We need to convert it into a linked list. Okay. So what we will do first, we will create a linked list, empty linked list. So linked list uh, yeah, array is equals to new linked list. Okay, what's wrong with this now? We have linked list. Okay, okay, it is correct. So we have created a linked list. Now we need to code int a in arr. What we will do, what we will do, we will do ln dot append a, and it will create the linked list, and then we need to print it. Okay, create from array. We need to do this. Let's add the method inside our linked list class itself. So we don't have to do it. Let's say what is the method that we create from array, right? So this is a linked list class, and here below next method we will create a public um, void create from array, and the input is int arr, and what it will do, it will iterate for, okay, and then it will have the head counter. So what it will do, for each loop for int a inside arr, it will only do, it will only append the current element to the linked list. So what it will do, how do we know that linked list? Hmm, right. How can I do that? Either I can update my linked list directly that I was in added to linked list. It was easier. mm, After creating a linked list. But inside the linked list class, how do I call the method of class? Mm, where is that? What we want to call append method, right? Where is it? Where is the append method? Print on get master. First one, range size, prints, display, append. It takes the integer data. So for that, we need to learn about the insert method first. Once we know how to insert at the beginning, we will use this method to do this. But for calling append method, that we can only do from our main method, right? In this, not here, but here. We can do this by creating a linked list. So let's say linked list or L is equals to new linked list and then to create like adding all the array elements to linked list, we will do for int a in arr. We will append l l l dot append a. So it will add all the elements of the array to the linked list, and then we can print the linked list using the method linked list.display l.display. Okay, so let's run it. So it has created an linked list from those array elements. Okay, this is done. Let's learn insertion mastery, adding elements everywhere. So learning goal, understand head manipulation for the front insertion. Task, write a prepend int data method that adds a new node at the beginning of the list. So let's come back to this part and forget about the create from array and create a method to insert a new node at the beginning. So, okay, let's name it prepend, uh, and it will return nothing. Public void prepend. It will take int data, and then using prepend, we need to create a new node and insert it at the beginning of our linked list. So how we can do that? To do that, let me think from the understanding that we have built till now. We can create a node h is equals to new node, and data will be data, right? The data given. Okay, so it will contain the data that we need to prepend, and then we will update head dot data is equals to, let's call it temp now, and we let it store head dot data, and then we will update head dot data with head dot data with the new data that we need to insert. Yes, is equals to data, and head dot next is equals to temp node, and temp node. Okay, first of all, we will add temp node dot next is equals to head dot next, and after that we will update. Okay, so basically what we are doing, we have created a temporary node and stored the data which was previously on the head. लेकिन ऐसा करने की जरूरत ही क्या है? हेड को हेड की जगह रहने दो, न्यू हेड कर दो इसको, लेकिन वी वांट के हेड का नाम हेड रहे, राइट? लेट्स कॉल इट n1 instead. New node is n1, and it will become n1 dot next, and it will n1. So we have created a new node and have stored the head dot data, okay, and updated the pointer to head dot next. Okay, now these both are pointing there, and then head dot data will become data, and head dot next will point to the N1 node that we have created. So I hope this should work efficiently. Let's try to do it. Mm, do it in the same array element. So same program array to list wala program. Okay. So insert at the beginning, we need to prepend. Okay. So we have displayed the linked list already. Now we want to prepend l dot prepend create new क्या prepend we have created this. We have already created a method. Then why it is not visible there? And what prepend? What we need to add some data. Data is 5. This is this. Okay, so it should work. Let's run it. And we will display the linked list again. L dot display. Okay, let's run it. So 5 is depended on the first head node. Okay, so I could learn some and solve it. So let's call it done. And the next problem is insert at a specific position. Let's do that as well. Let's create a new file for that. Traversal वाले में क्या प्रॉब्लम है भाई? Elf dot add what is okay. Add को append करते हैं ना पहले. So all of these methods we are creating by ourselves. That means we are doing it. तो इसमें क्या प्रॉब्लम है? Is never used. It is still working because this is in the same file, right? Okay, so we don't need to import it like that. Let's create a new file for problem number 4 underscore 04 underscore insert at dot java. Okay, let's learn how to do that. Insert at specific position. So count be increase करने क्या? Let's not increase the count. Let it be. Uh, Here we have PSVM. Let's create linked list. Linked list temp is equals to new linked list. Then ll dot up, sorry, temp dot append. So let's add more. So this is a linked list that we have created. Now we need to insert, we have already inserted at the beginning and created a program already. Now we want to insert at a specific position. So should we create that inside our, so prepend method we have already done. The prepend method you inserts a new node at the beginning of our linked list. Now we will create a insert at method which will insert a new node at a given index. Insert at insert at int mm, position, right? Position and int data. Okay. So it will take a particular position and insert the given data at that particular position, right? We have to do this. So how we can implement that? We will create a new node and store the data in that new node. Node n is equals to new node, and it will store data. And as we want to, okay, we will create a count, and count is equals to 0, and while count is not equals to position, what we will do, we will also create a node current is equals to head. So it will traversing, it will keep traversing until we reach to that mm, while count is to equals to position. Then what we will do, we will update current is equals to current dot next. Okay. When current counts and also increase the count plus plus. This way we are tracking the count. When the count will become equals to position, what we will do, we will update. So we will reach the position and we want to insert. Okay, first take this. If position is equals to 0, then what we will do, we will prepend data. Okay, so this is very basic. And then mm, we need to traverse to position -1. So when count becomes equals to position, so we want to reach only position -1, and staying there, we will update. So now what we will do, we will update n dot max is equals to current dot max, and current dot max is equals to n. This way, we have just inserted a new data as some position. Let's try to run it. Let's say we want to insert 30 after 50. So the position will be index number 1, 2, 3, 0, 1, 2, and 3. 0, 1, 2, and 3. 3 plus 0, 4. So we want to insert at that. So temp dot insert at position will be 3 and data will be 30. Okay. So we want to insert 30 at index 3. Index 3 is this, right? So before that, also print the linked list temp dot display. It will print the linked list before the insert operation, and then we will print uh, temp dot display after insertion. Let's run it. So 30 is inserted at index number 3. So we are right, and we have correctly inserted the given data, right? So insert at specific position is also done. Let's move to the next problem. Insert after given value. Searching and insertion will be done. Insert in sorted order. Practice conditional insertion logic. Deletion skill. Delete from beginning. Delete by value. Delete at position. Okay. Now let's jump to the Striver sheet. I think this much of basic is enough for solving these problems. So insertion at the head of the LL that we have already done right now. So inserting at the head is like, so we need to, for inserting, we will create a new head. Is it visible? No, it is not. Mm, Now I think it should be visible to you. मेरी ही आवाज शुद्ध है लेकिन हाँ मुझे so what we will do, we will create a new node. Okay, इसमें क्या implementation भी है list node. ठीक है list node and is equals to new list node with data x. Okay, so we have created a new node which will store the data that is given, and then what we will do, we will update. So the head will become, first we will store and dot next is equals to head dot next. Okay, so it will be pointing to the second node. Okay, and then we will update head dot next is equals to n. So it will be pointing to the newly created node. And then what we will do, okay, we don't need to store it here. We will only update n dot data is equals to head dot data and head dot data is equals to data, right? इसके variables अलग अलग हैं सारे. So what are the things I need to update? It is giving value. So new is okay. So next is okay. Next is okay. But data is not okay. So and dot value is equals to head dot value. Okay, and head dot value is equals to data. Okay, now let's try to run it. Head dot value. ये मैं मेरे वाले इम्प्लीमेंटेशन में कर रहा हूँ तो वर्क कर रहा है. We are given head, we are given the data x, we have created a node using this constructor, right? So it contains the data and the okay, list node equals to new list node. Then n dot next is equals to head dot next, it is right. Head dot next is equals to n, it is right. N dot val is equals to head dot val, it is right. Okay, but head dot value is will be integer type, right? Cannot find single right. Why you could not find a single? What is your ChatGPT from here? Oh. New node dot next is equals to head. Return new node. इतना सिंपल था क्या? लिंक लीड कोड वाले प्रॉब्लम्स करते हैं यार. दिस इज स्टूपिड. लर्न वन डी लिंक्ड लिस्ट इसमें एक ही है डिलीटिंग अ नोड इन अ लिंक्ड लिस्ट. लेट्स डू दैट. Delete a node in a linked list. There is a single linked list head and we want to delete a node in it. You are given the node to be deleted node. You will not be given access to the first node of head. Then how am I supposed to delete? There is a single linked list head. You will not be given access to the first node. Then how am I supposed to access the linked list if I don't have access to the head? Okay, I have this node, but it is a single linked list. How can I access the this? Inserting a node in a linked list, we have done that. Deleting a node, we need to do it. Find the length of the linked list that we have done. Search an element in a linked list that we have done already. Because there is no deleting a node in a linked list is remaining, then we need to learn doubly linked list. Medium problems of linked list are there where we have done this. Reverse a linked list. These problems we have to do today. There are 15 of such problems. Okay, deleting a node in a linked list. What can be done? We have this node. We can access the nodes after this. How to access the previous node? Okay, let's read the article. Given a linked list, delete the tail of the linked list and print the updated linked list. इसमें तो बस ये बोल रहा है कि लास्ट वाला वो हटाना है. But in that lead code problem, it is saying that you can't access the head. And if I can't access the head, how am I supposed to delete any node? Acceptance rate is 83%.
मैं ऐसे इंसर्ट एडेंट स्ट्रिंग, लेकिन इस क्लास को मैं एक डेटा स्ट्रक्चर की तरह समझ रहा हूँ। डिफरेंस देखना दोनों में। ठीक है, अब मैं किस कहाँ पे था, हाँ डिस्प्ले। तो यहाँ पे जैसे मैंने यहाँ पे एक फंक्शन बना दिया इसका, तो एक और फंक्शन बना लेते हैं यार, वॉइड डिस्प्ले। एक और चीज़ आप ही सोच रहे हो कि इसके आगे पब्लिक स्टैटिक क्यों नहीं लगाना, देखो ये ऑलरेडी इसके अंदर है पब्लिक स्टैटिक में, तो बार बार लिखने की जरूरत नहीं होती। अब वॉइड डिस्प्ले ये भी क्या रिसीव करेगा, नोड हेड। हमें बस एक अपना हेड दे देंगे, और मैं पूरी की पूरी चीज़ डिस्प्ले करना चाहता हूँ, आप सब जानते हो बहुत ज़्यादा आसान है। बस इसमें यहाँ पे लिखना है वाइल हेड, और डायरेक्टली मेरी लिस्ट ऐसी बन जाए, ये इससे कनेक्ट हो जाए। ठीक है, और फिर सेकंड इंडेक्स बेसिकली दिस इज द एल्गोरिथम। ऐसे तो आपको यहाँ लो, यहाँ पे ये करोगे इस -1 इन में। अब ये मेरा प्रेजेंट डॉट नेक्स्ट है, ये टेम्प डॉट नेक्स्ट दो लाइन की इस्ट हो गया एक का नेक्स्ट। ये था इसका टेस्ट कुछ ऐसे पे उसका करके देख करते हैं।
लेकिन
देन
अगर
ये
हेड
एक
का
बस
एक्सेस
एक
ही नहीं होगा तो
तो
हाउ एम
यहाँ
आई
एक क्वेश्चन
सपोज्ड टू
पाओगे,
डिलीट द नोड?
नेक्स्ट नहीं अब जाना, ध्यान से वो है इंडेक्स, ये डिस्प्ले हट गया, जीरो देखते हैं डॉट डेट नहीं टेल का हम भूल गए, तो यार टेन है 4 पे टेल 2 था, और हेड भी यही है अभी के लिए 5 बना था, यानी कि नेक्स्ट था अरे गया को करनी थी। अब इंडेक्स से एक नहीं हटा, यहाँ पे इंडेक्स इफ इंडेक्स इज जीरो, इफ इंडेक्स इक्वल टू जीरो, तो क्या नल एल डॉट मेरे को क्या, तो इससे पिकिंग किया हेड को। ठीक है, रन करते हैं एक बार कोड पे, दो काम, एक और प्लस माइनस या फिर कुछ। ठीक ठीक, तो हम इसके वेरियस फंक्शंस बताए आपको।
Hey there everyone and welcome back to the Geek of the today's video. So we have to very easy and has been asked in many big companies like Amazon, Goldman Sachs, Samsung, Microsoft, Visa and Critical Solutions. So the questions is as below. We are given a pointer reference to the node which is to be deleted. Pointer reference to the head node is not given. Reference. Okay. So the input is like this. So the first line of the input contains number of test cases t, and for each test case first line of input contains length of the linked list, and the next line contains the data, and the last line contains the node to be deleted. So the output should be, we have to print the linked list after deleting the given node. And our task, again this is a function problem, so we only need to complete a function delete node, and all the rest of the work is done by the driver code. The constraint put first line is t, number of test cases we are given, and this is the first test case and this is the second test case here. Okay, so the first line of the first test case give us the number of nodes in the linked list, so there are two, so there are two nodes 1 and 2. I have just done a picture representation over here, and we have to delete first element. Okay, this node we have to delete this. So what would be the output? This will go here and the output will be only 2, as you can see. And for the second, we are given 4 nodes 10, 20, 4, 30, and we have to delete 20 from them. So again, this is a picture representation of the second input, and we have to delete this node. So what will be the output? Seems like it will goes like this. So this node will be deleted. 30 solve this problem. So there are basically two approaches we are going to take. First is this and second is this. Okay, so first you can do we can do this by swapping the values. Again, this method is a lot more efficient than the second one and requires a good control over the pointers, and there are some chances of memory leaks in this. And the second approach is,
Okay. ठीक है, ठीक है, ठीक है, ठीक है. I got something. Okay, simple. If we are given the current node and we need to delete it, so what we will do, we will swap the data of the next node with this node, and then we will delete the next node. Okay. Okay, okay, okay. So let's say, let's create int temp is equals to node dot value, right? Use not real value. Okay. So we have stored the current data of the current node, and now we will update the node dot value with node dot next dot val. Okay, so it will store the value of the next node, and then we will delete the next node. Okay, so how do we delete the next node? By node dot next is equals to node dot next. Okay, and simple. Is it? Is that it? Let's try to run it. I think what is going to do. Yes, it is right. Oh, you have to swap the current node with the next node. Okay, it is working. चलो finally एक solution तो हुआ खुद से. And the another other way was, what was the other way? Copy the data of the next node to the current node, then link the node after the next node to the current node. This way next node is removed, but its data is saved. Okay, these both the approach are same. Okay, so this is done. Finally linked list का problem हुआ. Okay, and how many approaches are there? I think it has only one approach. What it does that there is the implementation. Delete tail head equals to null head dot null. Return null node temp equals to head. Not equals to null temp equals to temp dot next temp dot next equals to null. Oh, so much bullshit. Here we have done all the basic problems, and now we should start medium problems, right? Then we will learn doubly linked list later. Middle of a linked list. Tortoise have a method, I don't know, but I have solved this problem on lead code as well, right? On lead code we haven't solved it. Let's solve this problem on lead code. Let's quickly solve it. So the definition of single linked list is given as public plus list node int value list node next. int value, this dot value equals to value. Okay, this dot next equals to next. Okay. What we need to, given the head of a singly linked list, return the middle node of the linked list. So how we can return the middle? We cannot use that linked list, built-in linked list, right? Linked list class of Java. So what we will do, we will create a int count equals to 0, and while head is not equals to null. Okay, one more thing, we will have to create list node current is equals to new list, sorry, current node is equals to head, and while current node is not equals to null, we will keep iterating. Current is equals to current dot max and count plus plus. So first we will count all the number of nodes in it. After that, what we will do, time it Thursday 10:55. So we will count, we will increase the count, and then we want to return. So we will iterate again. Int middle. Let's say if count modulus 2 is equals to 0, mm, okay, we have to do that also. What if count modulus of 2 is equals to 0? That means it is even. What we will do, we will update count as count is equals to count by 2 plus 1. Sorry, if it is odd, then we will do this count by 2 plus 1. If it is odd, the number of node is odd, 2 plus 1. Else count is equals to count by 2. So while count is greater than 0, we will go from what we have to do. If there are two middle nodes, return the second middle. So second middle is going to be 1. Yes, it should be 0, right? Okay. And the return the middle node of the linked list, right? So Mm, how is it interesting? Current first we have, and we will update current is equals to current dot next count minus. So once count becomes 0, we will return current. I think it is the exact implementation that I want to. Mm, okay, semicolon is here. ठीक है एक टेस्ट केस सही हुआ एक गलत हो गया लेट्स सी व्हाट wrong we did. So we want to middle of the linked list, right? It is even when we divided x. Return the middle node of the linked list. भाई तो मिडल नोड तो एक ही होएगा ना 4 5 6 एक्सपेक्ट क्यों कर रहा है अच्छा लाइक इट रिटर्न फंक्शन it is working fine. We don't have to do anything with that. Okay, so finally we have started solving real problems. Reverse a linked list iterative and recursive. What are the two different ways to reverse a linked list? Let me come up with a solution by myself. Let's create list node temp equals to heads. चलो एक टेम्पररी नोड बना दिया and let's say it stores head dot next. That means it is storing the second node. We also need to check if the given linked list is not empty. Okay, we will think of edge case after implementing the basic solution or logic. Let's say we have a temporary node which stores the second element for the node, and if we update the actual second node with to point to the first node, but we have a temporary node which is pointing to which is acting as this and will be pointing to the third node. Okay, okay. And let's say list node current is equals to head while current is not equals to null. So while current is not equals to null, we will keep doing what? We will updating that is head dot next dot next is equals to sorry current dot next dot sorry mm, I'm thinking that this is first node, this is second node, this is third node, this is fourth, this is five, and these all are pointing to the next node. Okay, and I have a temporary node which stores the second node. Okay, temp is acting as the second node and pointing to the third node. Okay, so if I change the pointer of the second node to the first node, I still have a node which acts as a second node, right? So I have updated the second node to point to the first node, and then I will update temp dot next temp is equals to temp dot next dot next. Okay. I also need to keep a call. Okay, this thing I'm getting एक टेम्पररी नोड लेके चलेंगे और इसमें स्टोर करते जाएंगे, but so this is the current node, this is current dot next, and this is current dot next dot next. We are storing head dot next in a temp. Okay, So these are the 5 nodes, and we want to reverse it, right? So let's say this is node 1, this is node 2, this is node 3, this is node 4, this is node 5, right? And it contains data as 1, 2, 3, 4, 5. Okay, and it points to M2, it points to M3, it points to M4, it points to M5, and this points to null. Okay, so what we will do, we will take a temporary node, node 10, let's call it T. It will store, focus, first node से start करते हैं. So it will store the, copy the first node. So we have created it, it is pointing to this, and we will update its pointer to null. Okay, so what we will do, we will update its pointer to null. It will become null. Okay, then what we will do, we will temporary dot next का जो pointer है उसको head की तरफ point करवा देंगे. So it will become, but इससे पहले क्या हम करेंगे, इससे पहले हम करेंगे, अभी ये किया, इसके बाद में जो हमारा जो टेम्प वेरिएबल है ना, इसको अब हम नेक्स्ट पे पॉइंट कराएंगे. दैट मीन्स नेक्स्ट को अपडेट कर देंगे यहाँ पे. It will become it is pointing at the first one right now, and we will update it to be the next pointer, right? Okay, now I got it. We will update it to become the next pointer, that will be pointing to M3 and storing the second variable, and also pointing to the 30, right? That will be like this, and we'll update it to point the previous first node. Now we do that, but Let me think of it. T dot next. Okay, we will keep two pointers and both pointing to the same thing. ठीक है? M equals to head. Okay. And current is equals to head. While current is not equals to null. What we will do now, we will update temp and current both are pointing to the same thing, right? And we will do head dot max is equals to null. ठीक है? Okay, head dot max equals to null. चलो फर्स्ट स्टेप में जो पहला है उसी को नाम कर दिया. Now T is also pointing to that, C is also pointing to that, and we will update okay, current will be head but next, temp will be head. We have updated head to point to itself. Now we have temporary as head, and we want to now I want to update temp is equals to temp dot next and current. Okay, okay, okay. ठीक है. Current is equals to sorry, current dot next is equals to head. Head dot next equals to null. Current is now I created a temporary node. Let's say T is equals to head. So it will store one pointing to second. It is temporary node. Mm, okay. And there is also current node. Now if I have changed the reference of the head to null, it has no connection with the next node, but I have temporary node which was acting as the head node, which is pointing to the next node. Okay. And now I want to update the next node to point to the head node. That was the previous node. Hmm. Brute force optimal approach too. Let's see. Brute force. ठीक है. Temp बनाया. Head and temp are pointing to the same. Temp. Okay. Create an empty stack. This stack will be used to temporarily store the nodes from the original linked list as we traverse it. Traverse the linked list using a temporary variable temp. तो ये तो easy है. Like it is. Hmm. ये तो चलो ठीक है. स्टैक के बारे में मैंने सोचा ही नहीं. Iterative reverse link in place. Previous approach uses ON addition space which can be avoided by interchanging the connecting links of the nodes of the link list in place. So how to do that? The main idea is to flip the order of connection in linked list. Okay. Temp pointer से initiate करेंगे at the head of the linked list. This pointer will be used to traverse the linked list and initialize the pointer previous to null to keep track of the previous node. The entire linked list by moving through each node using the temp pointer until it reaches the end. At each iteration within the traversal, save the reference to the next node that temp is pointing to in a variable called front. This will help you retain the link to the subsequent node before assuming the next pointer. So there is previous null, it is current temp, it is front. And on the first step, we have updated to the previous. And previous will become temp, and temp will become front will become next. So we have to keep three variables or nodes. अरे इतना इजी था. सेम ही सी चीज मैं सोच रहा था कुछ. So we have to have three nodes, right? And list node progress is equal to null, and while temp is not equals to null, then what we will do, mm, we will create a node. List node front is equals to temp dot next, and then we will update temp dot next is equals to previous, and previous will be equals to temp. Okay, and find creative pursuit. Point of next. Next node and progress node contact and profit. And what is the second most optimal solution? Recursive problem. How do I do it recursively? Let's see it. Hmm. Problem statement, smart problem, smart problem, use case. Node new head is equals to reverse list head dot next. Front dot next is equals to okay. Hey Priyanshi, what is up? Let's do this recursively. In case we move to it, let's now new head and front. Okay, so new, new head is equal to head dot next and we'll do recursive algorithm के लिए पेशकश करने के बाद हाँ four dot max equals to null even to second. Then we will call the function recursively. Then we will go for list now count is equal to head dot max This is the head. And you want to that no for the person you will create no non response to reverse of hard documents. Add dot next. One that is to hard documents. Okay, we got it. So first the reverse list method will be called and it will check if the head is pointing to null or not. If it points to null, it will return head, and then we will create a new node, new head, and will reverse the next node, like give the next node to the same recursive function, right? And it will keep doing this until it reaches to the last node, where the last node it will point to the null pointer, and when it will point to the null pointer, it will return the head, that is the last node. Last node will be returned as the head, and after the last node is returned as head, it will be stored it will store head.next in its front node. That is null. Null will be stored in front, and front dot next will equals to head. No Pythons, charger buds. It will store head.next in its front node. Iterative approach was easier. Previous को null रखो, front को next रखो. That will be stored in front, and front dot next. Previous को null रखो, front को next रखो. That will be stored in front, and front. Is the code on connected. Okay, let's do the next problem. Detect a loop and linked list. Find the starting point and linked list. Length of loop and linked list. Check if linked list is palindrome or not. Segregate all the unique elements in linked list. Remove answers from the back of the linked list. Delete the middle node of the linked list. Sort linked list. Let's try to solve this. Detect the loop in our linked list. Given a head, the head of a linked list determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the linked list that can be reached again by continuously following the next pointer internally. If I look at Previous column next. Learn first pointers. What's the correct one? What am I doing wrong? Cannot read field next because local 3 is not. What does it mean if local 3 is not? I see your code is attempting to detect a cycle in a linked list using the Floyd's, tortoise, and hare algorithm, which is correct in principle. However, there are few issues in your implementation. Issue in your code, your while condition is unsafe. If fast becomes null, fast.next will throw a null pointer exception. Okay, you must check both fast and fast.next in the loop condition. Okay, you initialized fast is equals to head.next, which is fine, but you need to handle the first comparison carefully. Usually both pointers start at head. What does it mean? Fast is not equals to null and fast.next is not equals to null. Mm, this is what I was keeping on missing. Hard and right. Still getting this exception. ये बस आगे पीछे करने से क्या डिफरेंस आ गया? Slow and fast counters to detect the looping linked list. Find the starting point and links. Given the head of a linked list, return the node where the cycle begins. We need to detect the starting index of the cycle. The cycle can be detected using two pointer. So it is that index which can be reached again and again through the loop as well as from the head. Hmm. So what we did, we ran the fast and slow pointer two times. The camp tied. So we will continue from here tomorrow. I'm ending this stream. Although I wanted to complete all the problems from link keys, but we can't. Okay, thank you so much for everyone who has joined.